This video is about the chain rules for the multivariable functions. If your function, we learned the chain rule before, for the function depends on single variables. For example, y depends on u, and the u there depends on x. Therefore, your y eventually depends on x. So the chain rule for this kind of composite function is like dy dx is equal to dy du dx. So the chain rule for the function depends on single variable functions, just one formula like that. Okay. However, for the function depends on more than one variables, the chain rule is more complicated. For example, z is a function of x and y, and x here is a function of a t, say ht. Y is also a function of t, say g of t. Okay. So what's the chain rule for? Therefore, your z there eventually only depends on t, right? You can replace x there by ht, y by g of t. Okay, now, so we can find dz dt. Okay. We use d here instead of a partial because my z is really dependent on only one variable eventually. Okay. So the chain rule for this is partial f respect to x, then dx dt. Okay. Since your y also depends on t, so you have to find the partial f respect to y, then dy dt. Okay. Since z equal to f, so this is just really same thing. Partial z respect to x dx dt plus partial z respect to y dy dt. Once we use a partial, that means that function depends on more than one variable. We use d means function depends on one variable. Okay, let me give you an example to show you this formula makes sense. For example, my z here is x to the fifth plus sine y. Okay. And my x here depends on t. It's like, say, cosine t. My y here also depends on t, say, for example, ln t. So you can plug in here, replace x by cosine t, then you got cosine t to the fifth, then plus sine replace y by ln t. Okay. So your z here is dependent on single variable t. So we do know how to find dz dt, right? By learning the Cal1. Okay. Use chain rule, give you 5 cosine t to the fourth power, then take derivative inside respect to t, give you negative sine t. Okay. Then plus, use chain rule, give you cosine ln t times take derivative inside, give you 1 over t. Okay, now let's calculate dz dt again by using the chain rule we just learned. Okay. So if you're using this formula here to find the dz dt, which give you partial z respect to x dx dt plus partial z respect to y dy dt. Okay, what is a partial z respect to x? Now, my function here is z equal to x to the fifth plus sine y. You take a partial derivative with respect to x. That means you treat y as a constant. So the first one you take a derivative will give you 5x to the fourth, then plus take a derivative of the second one. Since you treat y as a constant, so you got plus 0. Okay. Partial z respect to y. This time you treat x as a constant. So the first term you take a derivative give you 0, plus second term you take a derivative with respect to y give you cosine y. Okay, obviously dx dt would give you negative sine t, right? Because my x equal to cosine t. dy dt here give you 1 over t. Okay. So you put them together, your dz dt here really is 5x to the fourth, then times dx dt, which is minus sine t, plus partial z respect to y, give you cosine y, then dy dt, which give you 1 over t. Now, if you replace x here by cosine t, you got this. Replace y by ln t, then times 1 over t. Okay. So you got exactly the same as what we got before. Okay. The purpose of this example just show you the chain rule for the function depends on more than one variables. This really makes sense. Okay. Okay. As I told you, there's for the function depends on more than one variables. The chain rule is just not just one formula. There's many situations. The second example is my z depends on x and y. Okay, then my x depends on two variables, 2 s and t. So is my y depends on g's of s and t. Okay. Therefore, your z there eventually depends on x and t. Okay, depends on two variables. So we can talk about is partial z respect to t. Okay. Here we use partial because my z there depends on two variables, s and t. Okay. So the chain rule for this kind of situation is partial z respect to t equal to partial z respect to x because my x depends on t. Okay. Then partial x partial t plus partial z respect to y, then partial y respect on t. Similarly, you can find the partial z partial s. Okay. Okay, is partial z respect to x, partial x respect to s, plus partial z respect to y, and partial y respect to s. Okay, now you have to read the book for more situations. Okay. Now, this chain rules can be used to find the differentiation for implicit function. For example, I have a function like this. Okay. Let me ask you, what is the graph of that? This is really equivalent to say what? This is the implicit form for the function like this. So obviously this is what? Curve, okay? It's not a surface. So your y here really depends on x. Therefore my capital F depends on x. Come on. Okay, now what I want to find is what? dy dx. That's what we want to find. Okay, now Look at this equation. The left hand side is a function of x, so is the right hand side. So we can take derivative with respect to x on both sides of the equation. Okay, what is this? Remember using chain rule. Okay, my capital F depends on x and y, but the y depends on x. So use the chain rule. This will give you partial f respect to x dx dx plus partial f respect to y and dy dx. Okay. And the dx give you 1. And d, you take a derivative of 0. 0 is a constant function. You take a derivative to give you 0. Therefore, this equation means partial f respect to x. Since dx give you 0, then plus partial f respect to y dy dx. The right hand side, you take a derivative of 0, give you 0. Okay. So you solve from this equation, you find your dy dx, which is equal to minus partial f respect to x over partial f respect to y. So we use chain rule and we find the derivative for this implicit function. Okay. Similarly, we can do that for the function for this kind of implicit function. Ask yourself, what's the graph of this? This looks like your function depends on 3 variables. Really, it's not. You can solve from here. You solve the z. Okay, z there. You can think about it as a function of x and y. Okay. So obviously, this is what the graph of this equation is. What? Surface. Because this one is a surface. Okay, so look at this equation. Left hand side, your left hand side, x, y, really depend on 2 variables, x and y, because my z depends on x and y. Okay. So what we're going to do next, since for this equation, left hand side is function depending on x and y, so is right hand side. So we can take a partial derivative on both sides. Okay, now let's find what is this. Okay, use the chain rule. Okay, this gives you partial f, partial x, partial x, partial x, plus partial f respect to y, then partial y respect to x, plus partial f respect to z, then partial z respect to x. Okay. In this equation, partial x give you 1, and the partial y respect to x give you 0, because x and y, they are not related. Okay. What we're looking for here, we're looking for partial z respect to x. Okay. So put this one back in the equation, we got this. Partial f respect to x, partial x give you 1. Then this term is 0 because of this. So give you partial f respect to z, then partial z respect to x, and 0 you take a partial derivative respect to x to give you 0. So solve from this equation, I can get a partial z respect to x is equal to minus partial f respect to x over partial f respect to z. Okay. Similarly, we can find the partial z respect to y. Even negative partial f respect to y, the same denominator. Okay, now let's look at the example. Example, I'm using the example on the exercise page. Okay, we have a equation like this: yz equal to ln x plus z. Now, so this, what's the graph of that? If you are able to solve the z, you can think about something like this: z equal to function of x and y, right? If you are able to do that. Okay. The reason we use the implicit function because in many situations we're not able to solve the z and write in this form. Okay, now if we want to use this formula, what do we want to do? We want to find partial z respect to x and the partial z respect to y. Okay. If we want to use these formulas to find this, so the first thing we need to do is what? Find what is a capital fxy and a z. So what do you need to do here? You subtract ln x plus z, you got this. That's the first thing you need to do. Move everything on one side. Okay. So your fxy equal to yz minus ln x plus z and equal to 0. Write your equation in fxy equal to 0 form. Okay. Then next thing we need to do is find the partial f respect to x, partial f respect to y, and so on and so forth. Okay, now let's find the partial f respect to x first. Okay, we're looking for partial f respect to x. That means you treat yz as a constant. So you take the derivative of first term, yz, there's no x, you treat it as a constant, give you 0. Then take the derivative of second term, give you minus 1 over x plus z. Then you take the derivative inside respect to x. Then treat z as a constant, just give you 1. Okay, now let's find the partial f, partial y. Okay, now we're talking about the partial f respect to y. That means you treat x and z as a constant. So the first term you take partial derivative respect to y, treat z as a constant, give you z. Second one, treat x and z constant, you got a 0. Okay, so that's it. Then partial f respect to z would give you the first. Okay, this time we treat y and x as a constant. So the first term give you y. Second give you minus 1 over x plus z. Then times the derivative inside respect to z. You take the derivative of x, give you 0, and z give you 1. That's it. Okay, now we have everything, so we can find the partial z respect to x. Give you minus partial f respect to x, partial f respect to z. Write down everything clearly. That will reduce your chance to make a mistake. Okay, my partial f respect to x give you minus 1 over x plus z. And partial f partial z give you y minus 1 over x plus z. I just leave like that. You can simplify this. Okay. Now in the test, if you want to simplify this, make sure you do it correctly. Otherwise, I'm going to take a point out. Whenever you made a mistake, okay. Partial z respect to y. So using the formula, give you partial f respect to y over partial f respect to z. So you just plug in things. Partial f respect to y give you z. Partial f respect to z give you y minus 1 over x plus z. Okay, we're done.